Hello, so today we are going to do this contest, bi-weekly contest 92. The first problem is minimum cuts to divide a circle. So with this problem, what we have is that we have a circle and we have this concept of a valid cut, where basically it can be one of two things: either a cut that is represented by a straight line that touches 2 points on the edges of the circle, and passes through the center at the same time, so sort of a diameter here. And the other option for a valid cut is that it's a straight line that just touches 1 point on the edge of the circle, not two, just one, and it goes through and it ends in the center. So from center to one edge, or from two edge and passes through the center. So those are the two valid cuts. So here are examples. So this one, a valid cut, it's from the first option, and this one is the second option, and this one is not a valid cut because it doesn't go through the center and touches two edges, right? Touches two edges but doesn't go through the center here, right? So that's the idea. Now what do we want to do? So we get n, which represents number of slices we want to make in the circle, and what we want to return is the minimum number of cuts, so that we can divide the circle into n equal parts, right? So the minimum number of cuts we need to do, either the first option or the two option, doesn't matter, but we want them to be equal slices. The equal part here is important, right? Okay, so let's take a look at a couple of examples here. So the first one, n equal to 4, so we want n equals 4 equal slices. So we can do 2 cuts using the first option, which is the edges and the center. So we get 1, 2, 3, 4, and they are equal. If we have 3, to get equal, we have to divide using the second option, but 3. The first one is this one here, the second one is this cut here, and the third one is this cut here, or whatever order you want, it doesn't matter. But this is the only way to get equal parts. So 3, 4, 3. So that's the idea. Now let's see how we can solve this and go through some examples. Okay, so let's just take a look at some examples here and see if we can find a pattern. So for n equal to 1, which means we want the minimum number of cuts to divide the circle into one equal part, right? It's already one equal part, so for n equal to 1, we don't need to do anything, so we just return 0, right? Now for n equal to 2, we have we can just do one cut, right, in the diameter, the first type of cuts, so from that touches two edges and passes through the center. So with that we get 2 equal cuts. You could also do it vertically or horizontally, right? It doesn't matter which option. So cuts equal to 2. So we need so here the number of cuts we need to do, let's just write this, the minimum number of cuts. Here we need 0, and here we just need 1, right? If we take a look at numbers for n equal to 3, we have to do something like this to get equal parts, and we have to do it with the center from here and here and here. You may think, okay, why not just do 2, one cut from the diameter like this, and then one like this, right? But the problem is these are not equal. This is just 2 cuts, not 3, but not equal, because this one is bigger than these 2, right? So this one is not a valid one, right? Because we want 3 equal cuts, and so we have to do something like this, or you could do it in reverse like this. But the minimum number is 3 cuts, because what we are doing is 1 here, and then 1 here, and then another 1 here. So the second type of cuts. Okay, so for n equal to 4, well, for that one we just need 2 cuts from the first type, one in the middle like this and one vertical like this, and those 4 are equal, right? So 4. Now for 5, it's a little bit complicated, right? It's sort of we have to do something similar to 3, but at a sort of 72 angle. So the 72 is coming just from 360 degree for the circle divided by 5, and so we get this first cut, this second cut, this sort of cut, and then this sort of cut, and these each will require cut 1, 2, 3, 4, 5, right? So for 5 we need cut equal to 5. You could try more the minimum cut we need is 5. So we could try more examples, but just going through these examples, you can notice a pattern here. So there is a difference between when n equal to 2 and when n is even and when n is odd. So when n is even, it's each time one. Sorry, here we need 2 cuts. So cut is 2. Let me just clarify here. So here the cut we need is just 2, right? So every time you can see for when n is even, right, we just need n divided by 2 cuts. And when n is odd, for example, n equal to 3, we need 3 cuts. N equal to 5, we need 5 cuts. If you try with n equal to 7, we'll need 7 cuts. So it's n when n is odd. And we have a special case here for n equal to 1. It's odd, but it's not 1 because there is already a 1 equal size. So except if n equal to 1, we need to return 0, right? And so it's a very straightforward solution. We just need to apply these 3 conditions, and each of them has this result and return it, right? Yeah, so this is one of those examples that you can just do some examples and you will see the pattern. So let's write this up and make sure it passes test cases. Okay, so let's write this up. So what we need is if n equal to 1, we want to return 0, right? Now if n is even, we need to, it's just n divided by 2. Now if it's else, it's odd, so we just return n, right? And that's pretty much it. Let's submit. Oh, sorry, that submit, and that passes test cases, right? So pretty straightforward here. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.